What comes to mind when you hear the words parallel universe? The term conjures up a number of images in the mind of realities like ours occurring in sequence with us. Parallel universes are an idea of both science fiction and perhaps science fact. Many top scientists believe that our universe is not alone in the void, and this possibility has captured the minds of many throughout the years. But what makes the idea of other universes so intriguing is that there are so many unknowns. Mankind has historically possessed an insatiable desire throughout history to explore and learn more about what lies beyond. Even though we still have a lot to learn, we can observe our own universe, and for a species stuck on a rock, we have a pretty considerable knowledge. But parallel universes, if they exist, are sealed off beyond the cosmic barrier. As such, we may never know how many other universes exist beyond ours and what they might contain, but this hasn't stopped us from hypothesizing. Even though these alternate universes are out of reach, there have been no shortage of theories and ideas in modern science that allow us to make educated guesses on what each one might be like. Today, we'll be taking a look at those hypotheses and looking at some of the likely forms we think they might take as we aim to discover what creation beyond our universe is like. If parallel universes, or areas that behave as parallel universes, exist, then the possibilities are potentially endless. This possibility is epitomised by the multiverse theory, a popular and well-known hypothesis that deals with parallel universes as if creation is boundless and there are no restrictions on size and matter. Cosmologist Max Tegmark identifies the forms that this boundless plane could take into 4 groups. A level 1 multiverse supposes an infinite universe. Parallel universes don't exist independently from one another per se, but the endless expanse causes large contrasting sections of our universe to repeat, as one would expect a multiverse to. This is due to the fact that the number of quantum states, or arrangements and orderings that energy can be in, is finite. Eventually, if you cross the infinite universe far enough, particles would eventually start grouping together in the same way to you and what you see around you. Right now, there are about 10 to the power of 10 to the power of 70 quantum states that a human-sized volume of energy can be in. If you travelled this many meters across an infinite universe or further, you would eventually expect to see exact copies of you. This wouldn't even require an infinite universe, but if the universe is infinite, then these quantum states would repeat not once, but at infinity. If that was difficult to understand, just know this: in an infinite universe, if it's possible, it's occurring. An infinite universe has no end. There's no limit to how many clones of you, clones of this planet, and regions that resemble our universe there could be. So that's a level 1 multiverse. A level 2 multiverse supposes that the universe is not infinite per se, but that it will expand at infinity. Eventually, its size in light years would exceed the number of quantum states, so you would have the same results, it would just take a bit more time. The difference with a level 2 multiverse is that the universe is always expanding, but some areas are theorized to stop stretching and form distinct pockets in space. We know that the universe is not a sphere expanding in every direction, it's more like a flat region with no clear center, and every part of space is expanding, like bread rising in an oven. These renegade pockets of space that stop expanding are like gas bubbles within the bread. This would create what is aptly known as a bubble universe. The interesting thing about these bubbles is that if they are not expanding, it's likely that the physical constraints in that region would be slightly different, a slightly different speed of light, perhaps, or different impacts of gravity within these bubble universes that are now considered to be somewhat independent. But in both these levels, we are thinking about just one overall universe. If we think outside of our own universe, we get a level 3 multiverse. Instead of an infinite universe, a level 3 multiverse theorizes infinite universes. Rather than one single isolated system of infinity, our universe is finite as we currently believe, and it exists alongside infinite other realities and copies of our own. This theory is linked to the many worlds theory, the idea that every variable factor in our universe creates a split. Every decision we make and every event that occurs proceeds differently in a different universe. Hugh Everett III's description of a level 3 multiverse compares it to rolling a dice. Every one of the numbers it can land on represents a different universe. These parallels occur in independent isolated systems, meaning, if this is the case, your exact copy or clone wouldn't be reachable, They would be sealed off in their own universe, like cells in a prison block. This idea also states that there are infinite universes, so every possible eventuality could be occurring right now and ad infinitum in the future. Just like with a level 1 multiverse, that means that there's a part of creation where you're dead, one where you become famous, and one where you murder everyone you love. The list of possibilities is both quite impactful and varied. But then again, this idea does seem somewhat wasteful. I mean, everything in our universe copied and pasted into a new universe over something as mundane as a coin flip? Well, it seems wasteful, but who are we to say that creation has a storage limit, so to speak? Perhaps outside of our finite universe with finite resources, anything can exist. Perhaps parallel universes that are more similar are somehow closer to one another. Perhaps there is a way to travel back in time to access different timelines and subsequently different universes, or perhaps they exist in different dimensions, never detectable or reachable to one another. These are all crazy ideas, but until we have an idea of what could lie beyond the universe, nothing is off the table. If we take an anthropocentric view to creation, we will most likely be mistaken. Admittedly, this is only one approach to the multiverse, the idea that parallel universes are stacked up against each other and are dominated by variables. There are other interpretations that suggest an infinite number of universes do exist, but they aren't dominated by uncertainty and are not related. Similar to the idea of a level 1 multiverse, but instead of one universe, creation is split across billions and trillions of parallel universes, but eventually, if you go far enough, you will find a universe identical to ours. But then again, based on what we have observed here in our universe, the multiverse theory leaves a lot to be desired from a scientific perspective. Its very nature seems unfeasible. What seems a bit more likely is that there are a finite or infinite number of universes that are directly connected, perhaps by some yet to be discovered phenomenon which acts as a replication mechanism. Our universe may be one of many, but it's hard to visualize how a multiverse would stack up without some sort of physical relationship between them. Something a little more scientifically viable may be that universes in fact respawn themselves and create child universes within them through some form of unexplained phenomenon. If this is the case, then we can begin to make some assumptions on what creation outside of our reality might look like. As with anything reproducing from a population, we would expect to see some form of natural selection, the survival of the best suited. Perhaps some universes create more than others, and these universes survive by inheriting key traits which make them, so to speak, good universes. We don't know what makes a universe more favourable for reproduction, but if we take ours as an example, then the question is, are we living in a typical universe or an atypical one? Well, there are many thought-provoking arguments for each side. On the one hand, our universe is approaching 14 billion years old, up to 22 trillion light years wide, or maybe even more beyond the boundary of the observable universe, and no end in sight for an unfathomably long time. It seems to all be going pretty well so far. This might mean that we live inside a typical healthy universe which shares commonalities with a largely similar population. On the other hand, even if we were to discover what creates these child universes, we'd still have no idea if we were part of a best suited one. There may be hundreds, thousands, or even millions of violent, volatile universes that do not support life but replicate incredibly well. Perhaps a life-supporting universe is a glitch or an inconsistency. Maybe we aren't typical at all, and we live inside a cosmic family tree of wildly different universes. After all, at the moment we have no way of knowing how many universes there could be. There could be 1 million empty, void-like universes for every one that supports life intelligent enough to comprehend it. So it's almost impossible to determine whether our universe, if it is indeed both a child universe and a parent universe, is a unique or a generic one. Perhaps the first step in understanding this mystery would be to understand what the mechanism is that produces the child universes. It's a pretty good bet that the strangest, most inexplicable things in the universe might have something to do with it. Black holes. Some believe that black holes, at their singularity, may create the conditions to produce a child universe inside them, which could grow and thrive independently from the parent. This idea is explained by John Wheeler, who supposes that a universe's ability to produce supermassive black holes is the defining feature that makes a universe well suited. The more black hole seeds it can produce, the more children it can have, and and so its laws and constraints stand to be inherited among a larger population. The idea that our universe began inside a black hole has received more scientific backing in recent years as humanity aims to better understand what caused something from nothing at the advent of the Big Bang. By looking at the maths behind white holes, it is feasible that a black hole's singularity could lead somewhere within it or beyond it. Black holes could be the key to the nature of our existence, but with that said, there are still numerous questions about how a child universe created inside one would compare to its parent. On the one hand, it's easy to speculate that every new universe born through a family would be similar, if not the same. Perhaps supermassive black holes take what is essentially a sample of atoms and matter in our universe and use that to define a new universe. This would mean that all our universe's children would be supposedly younger versions of our own universe. The same laws of physics, the same accelerated expansion, always on the same track we are. On the other hand, there could be some slight differences. Wheeler calls this reprocessing. The laws of physics in the child universe may be slightly different, but overall you could establish a general trend from certain characteristics. For example, every universe has its own finite speed of light at which massless particles can travel, even if it's different to ours. The laws of physics could exist in all these universes, but the benchmarks may be slightly different, but nonetheless the same laws have been passed down. The laws of physics could exist in all these universes. The benchmarks may be slightly different, but nonetheless the same framework has been passed down. The evolution process that makes natural selection such an efficient system is based on genetic mutations that happen to be advantageous in living organisms. So perhaps the process isn't airtight, perhaps it doesn't always work, perhaps something is not properly reprocessed in the new universe and it becomes a trait that is passed on. For example, gravity is unusually strong and propagates across space faster than light in a child universe, but this would make black holes more common and would lead to more child universes. With all things considered, it's crazy to think that we might be living inside a monstrous black hole, but what's even more difficult to comprehend is our parent universe. It would have to be billions of years older and millions of times bigger if it has evolved and aged in a similar way. This sounds obvious, of course, but there is something more concerning about this, namely the death of each universe. If our universe is typical among a population, then it stands to reason that similar universes may suffer the same eventual death as our own. We actually have a pretty good idea of how our universe is going to end for all intents and purposes, and this could be a problem for the parent when their time comes. This is due to the concept of entropy. In thermodynamics, entropy is defined as the thermodynamic quantity representing the unavailability of a system's thermal energy, often interpreted as the degree of disorder or randomness in the system. Whenever you do anything, or whenever anything happens, energy is converted into work, but during this process a little bit of energy is always lost, such as noise, excess heat, light, etc. Energy should transfer. I mean, we see a cycle of energy transfer here on Earth and out there in the universe, but there are leakages in the process consistently, and the availability of the energy in the universe is decreasing. What this means is that eventually, all energy in the universe will be lost to this unordered, dispersed and random share of energy in the universe, entropy, like ice melting into a glass of water. One day, all energy will eventually become homogeneous, so dispersed and spread out that its density will be very low and it will be equal and the same gradient across all parts of space. No processes will be able to occur, and nothing will be able to exist, evolve or thrive or ever happen again. When this happens to our universe, we call this event the heat death of the universe, and entropy means that the universe is unsustainable. Eventually, after a goggle years have passed, so that's 10 to the 100 years, the universe will enter its dark age. No usable energy, no stars, no galaxies, no heat. Eventually even the black holes will likely dissolve into nothing. Dark energy will continue expanding the universe because its energy field appears to behave inversely and independently to normal energy, and so the universe will become this incomprehensibly large, totally dark and cold vacuum. All signatures that the universe even exists will become unidentifiable, and while the physical system will still remain, it will be like a universal skeleton, and the universe will be dead for all intents and purposes. Imagine it as a brain death for the universe. It's physically still there, but nothing can happen or occur within it for the rest of eternity, and it will be doomed to exist that way forever. It's a very depressing future to be sure, but how does it all link into the black hole universes? Well, there may be universes out there that are much older than ours, our ancestral universes, which are much closer to suffering heat deaths. Black holes may be the last thing to go, but when they do, then what? We have no solution for the heat death of the universe. It's unlikely we'll even be around for that long, but perhaps the only way to escape this fate would be to dive into a singularity and hope to find a younger universe where entropy is lower. But if black holes eventually die through Hawking radiation, then what becomes of the child universe when its black hole is gone? Would the destruction of the black holes seal off the child universe independently? Or would it just delete the child, which would then delete the child's children, and so forth? If it does, then what about the oldest universe? Is it approaching this fate sooner than us? It's reasonable to assume that the Godfather universe, the one at the top of the family tree, will be significantly older than our own. But is it old enough to be entering its death era? And if so, when its black holes are gone, will it become a barren void and take everything in the family tree with it? Perhaps there is no way to escape it. When the oldest one dies, all subsequent child universes disappear. It's a terrifying thought and far-fetched. We will just have to hope that time runs asynchronously to the parent universe inside the child universe, so that we will never have to reach the point where the older parents suffer heat deaths. Maybe the singularity pauses time in the parent to give the child more time to evolve and spawn more children. Maybe that is a trait it evolved with, preserving the family tree, while other universes without black holes cannot sustain children universes beyond the lifespan of the original parent. Once again, everything I've just said is wildly speculative and nothing short of insane, but it's not impossible. Again, until we know what lies beyond the universe, or in this case what may lie inside a black hole, we cannot say that this is untrue. Perhaps cosmological inheritance is our gloomy, entropy-based destiny in the distant future. Because the idea of parallel universes is so ambiguous, the first two approaches we covered are the only ones we can really imagine that have any scientific plausibility. However, there is a third option, something that is a lot more obscure but still holds up as a theory. Currently, advanced mathematics is the tool we use to describe, explain, and predict what we see in the universe around us. If the universe is describable by mathematics, then perhaps mathematics could be the language or framework of any given universe. In fact, it was none other than Galileo Galilei that said, "Mathematics is the language with which God wrote the universe." This extraordinary statement opens up a number of interesting possibilities, because this idea supposes that if maths is reality, then any universe describable through mathematics could exist. This could be as massive as our universe, or as minute as a universe with one single atom. If it can be described, then perhaps it can exist. Currently, we don't know what compels the laws of physics to be what they are, so perhaps it's not a definitive framework for all possible universes. Perhaps there are entirely different universes with no light, gravity, and no laws of physics, but proceed in their own way. Obviously, there is a lot of skepticism around this belief, because while mathematics helps us predict new phenomena with relative accuracy, at the end of the day, we made maths up. Maths is base 10 notation because we evolved to have 10 fingers to count on. There isn't a set formula that we know of that is consistent and rigorous for describing all of creation. But if maths can predict new phenomena and allow us to look inside and beyond the event horizon of a black hole, then there must be something scientifically feasible about it. After all, who's to say that creation is bound by simply what we observe in this universe? What lies outside could be governed by a completely different set of rules, or even no rules. This would mean that literally nothing is impossible, like the episode of Family Guy when they attempt to navigate through the multiverse and see a myriad of different setups and realities. If the plane of existence which universes are born on is truly infinite, then every single plausible model could exist somewhere out there. Mathematical languages would describe them, and because the maths is rigorous, they exist somewhere. Speaking of mathematical languages, if we created a simulated environment and told it what we knew about maths and physics, we could run simulations to determine the feasibility of any universe we could imagine. And as for simulated reality, well, that's something else to consider. If an advanced species is technically sophisticated enough to simulate reality, then they might be able to create computer simulations powerful enough to simulate an environment, and they could use AI to simulate consciousness within it. We are fast approaching the technical capacity to do this. There have been numerous simulations of the entire universe, which are some of the most advanced computational models we have ever created. We're nowhere near close to simulating an entire universe and putting consciousness within it, but the pieces are all there. But then, if we can create consciousness in a massive simulated environment, couldn't a superior race create something like us? After all, we live in a universe that is describable by information, and theoretically, if you had powerful enough computers that weren't bound by friction and heat, you could simulate this entire universe right down to an atomic scale. It's for this reason that some argue that we are already living inside a simulation, governed by a set of computed rules that we perceive to be the laws of nature. If we could simulate a universe very close to our own, it would be considered a reality by definition to whatever is programmed to be conscious inside of it. This takes an entirely different approach to the idea of the multiverse. If all civilizations become advanced enough to simulate reality, then they could end up producing their own artificial universes with programmed life within. Some take this a step further and argue that all civilizations eventually reach this point, and reality is just an endless loop of simulation inside simulation inside simulation and so forth. But then, if you could master this technology, isn't this how you'd want to exist? If we could transfer our consciousness into a computer, we could live inside a perfect artificial universe, and then that would become our parallel universe. Wouldn't this be the goal of existence? Creating our own utopia to live inside? Perhaps parallel universes are common, but they are artificial and exist because advanced civilizations right across the universe create their own. Perhaps for every natural universe that exists, 10 simulated universes exist within them. If you think about it, it's a similar sort of principle to the black hole seeding to create new universes inside a parent universe. In fact, this is exactly what is outlined in John Smart's 2011 transcension hypothesis. He states that advanced civilizations could miniaturize computers so much that they would have the density of a black hole. If a civilization could deal with this immense gravity, they could hypothetically use the black hole to store their virtual kingdom and would leave our universe, living inside of the singularity in an artificial universe of their own making. This raises an interesting philosophical question. Because this artificially generated universe exists inside a black hole, doesn't that make it just as real as the organic universe, and just as real for those living inside? It becomes extremely difficult to draw the line on what defines a universe and what doesn't. Who's to say that simulated universes are not real when we may be living inside a simulated universe and just don't know it? Perhaps one day, we will discover the technology to turn simulated reality into a genuine, livable and desirable reality for humans, and perhaps that is the day that an artificial universe becomes a parallel universe. The multiverse, the cosmic family tree, and mathematical universes. Those are three of a number of ways other universes could exist and what they might be like. All three ideas are equally plausible in their own ways. It's likely that we'll never be able to look beyond the boundaries of our own universe, but that doesn't mean we won't one day be capable of creating our own universe. In the meantime, all we can do is merely dream of other dimensions, but as time goes on, we may yet get closer to solving the mysteries surrounding the nature of alternate universes in the future. As for the simulation, well, we'll have to wait and see. And with that, thank you very much for watching, and don't ever stop reaching for the stars.